All right. Good morning, everybody. So, I hope you guys had a good weekend. Nakapag-relax, though medyo sabi nyo nga dun sa sagot nyo sa homework, most of you had a very light first week of classes. So, hopefully masustain natin yung ganong hindi kabigat na workload for the entire semester. But of course, expect na medyo mas dadami yung kailangan nyo gawin in the coming weeks. All right. So just prepare for it. Time management and time management would be the key in coping and adapting to the academic workload because you don't have any choice, right? So yun, and then I think I already graded all of the submitted homework, so kindly check out my comments there. If you have some questions on how it was graded, then just let me know. There are some students who accidentally use some theorems contained in theorem 1.3. So when I give you an instruction, make sure to read it carefully and follow it to the letter. I'll try to be as specific and as literal in my instructions as possible. So sinabi ko dun sa homework, you are only to use results before theorem 1.3. Some of you inadvertently or siguro out of instinct used theorem 1.3.1 and theorem 1.3.2. Pero sabi ko nga, hindi nyo pa siya pwedeng gamitin. Some of you were very clever and they rewrote the proofs of those results and I cannot fault them for that. So pag meron kayong mga results na hindi pa na-prove tapos gusto niyo siyang gamitin or may mga results na sabi ko hindi niyo pa pwedeng gamitin, uh, merong ano doon, may palusot. Pwede niyo siyang isulat as a claim in your submission and then write a proof for that claim and then that would be perfectly valid. So check out your or the annotated grade and graded homework. So para makita niyo yung comments ko doon. I won't discuss it in details here in class. Some of you had very long proofs, which is fine, but there is a shorter way of doing things. But again, there are several ways on how to kill a mathematical cat. So bahala na kayong pumili ng method. But usually we want the more elegant solutions. But again, kung ano yung makuha yung proof, as long as it is logically sound and valid, then that's fine with me. Okay? So now we are on meeting number 3. Medyo delayed tayo from study guide number 1. For those who are self-paced or asynchronous yung learning mode, I uploaded study guide number 2 for you guys. Though ni-note ko doon na yung synchronous classes ay a little bit behind. I think we are half a study guide behind. So, but hopefully we can catch up this week. All right? So ano nga bang pinagagawa natin last meeting kaya medyo delayed tayo? Well, we talk about or we tried to axiomatize the set of real numbers by starting with the set R, undefined term, collection of real numbers, kahit hindi pa natin kilala kung ano yung laman ni R. And then we added two operations, addition and multiplication. And then we enumerated some of the things that we want R together with these two binary operations to possess. And they are axioms 1 until 9, A1 to A9, which are basically what we call the algebraic axioms or the field axioms. So sila yung axioms A1 to A9. And then field axiom siya kasi sa algebra, when you take math 111, you will see that any set together with two binary operations that has a similar property as A1 to A9 is called a field. And we want our real number system to be a field. So kaya inimpose natin yung A1 to A9, all right, before knowing how to carry out addition and multiplication in the first place. And then we look at some consequences of this action. So we have several theorems, hanggang theorem 1.3, which basically lay down the some of the properties that we have known before. Probably some of them are from elementary. And then pinakilala ko na rin yung mga number sets or known subsets of R. So nagsimula tayo sa set of natural numbers. Though I said I will not mention how they are axiomatically created, pero may mga curious kung paano daw nabuo etong mga numbers ito because these are also key in the way we we enumerate, or we try to give some members, or some concrete examples of members of R, right? So magsisimula yan lagi sa set of natural numbers. Or by the way, we already know two members nga pala ng set of set of real numbers. Kilala na natin na meron siyang laman na 1 and 0. Si 0 yung additive identity, si 1 ay yung multiplicative identity. And we will assume that these two guys are unique. 0 is not equal to 1. All right? So ito yung dalawang specific elements pa lang ng R na kilala na natin nung nagsimula tayo, right? From axiom, I think it's A3 and A7. Okay? Or yeah, I think A8. So para makita natin ano yung itsura ng iba pang mga members ng R, right? Nagsimula tayo sa mga subsets nila. First, we will create the set of natural numbers. And this can be created using Piano's axioms, which was discussed in Math 101, or for those who have taken Math 103, nireplay na doon yung Piano's axioms. So it's a set of 5 axioms that will create the set of natural numbers. So ang laman niya ay 1, 2, 3, 4, and so on. But Piano's axioms tells us that there is no natural number, kasi ang gamit doon ay successor sets, that there is no number whose successor is equal to 1. So pag in-enumerate natin yung natural numbers, wala tayong makikitang additive inverses para sa kanila. So there would be no natural number whose inverse is who is the inverse of 1. So because remember, to get an additive inverse, we want to know what is to be added to 1 to get 0. Pero galing dun sa Piano's axiom, pag nag-add ka ng dalawang natural numbers, what you'll get is another natural number. Tapos hindi natin dyan makikita elsewhere, hindi tayo makakita ng isa pang natural number pag in-add natin kay 1, ang sagot ay 0. So pagka sinabi natin na okay, ang set R lang natin ay equal kay n, wala tayong additive inverses. So that will tell us na kulang pa yung elements ni n para mabuo yung real number system, kasi bawat real number dapat merong additive inverse. So kailangan natin yung additive inverse ni 1, additive inverse ni 2, additive inverse ni 3, and so on. Okay? Kailangan natin yung isama kay n at isama kay 0. Alright? And this would be our next candidate for the set of real numbers. Okay? Pero kukulangin pa rin yan. Kasi makikita natin na, alright, lahat meron ng additive inverses, pero hindi lahat magkakaroon ng multiplicative inverse. So for instance, si 2, what should be multiplied to 2 to get the multiplicative identity 1? Kasi di ba sabi ng axiom in A8, dapat merong multiplicative inverse lahat ng non-zero real number. Alam na natin si 2 ay isang real number. Kaya lang, ano yung i-multiply natin kay 2 to get 1/2? To get 1, all right? Unfortunately, wala tayong makikita kay z na number na yon. Actually, it would be 1/2, which is not part of z. So we need to invent another symbol for the multiplicative for the multiplicative inverse of 2, which is 1/2. So doon nabuo yung set of rational numbers. Okay? So nilagay natin lahat ng multiplicative inverses ng mga natural numbers. Tapos we also use the fact that the product of two real numbers must be another real number. So when we multiply, say, 3 and the multiplicative inverse of 2, whose symbol is 1/2, we will get another real number. Tapos wala pa siya dun sa original listahan, so kailangan mapasama si 3/2 dun sa listahan ng candidate natin para maging R. Alright? And so on. So essentially, people discovered na to exhaust all of these possibilities and satisfy the pagiging binary operation ni multiplication, ang laman ni Q dapat ay lahat ng mga numbers of the form m over n, where m and n are integers, but n is not equal to 0. Alright? Para lahat ng multiplicative inverses ng elements ni Z ay na kay Q, ang product ng lahat ng mga multiplicative inverses at mga integers ay na kay Q pa rin. Dapat ito yung itsura nung set natin. Tapos akala ng mga tao for several years, for centuries, that Q is equal to R. Akala nila lahat ng real number kayang masulat as a ratio of two integers. But the Pythagoreans discovered with proof that there are some numbers that cannot be written as a ratio of two integers. For example, is pi, all right? And actually, di pala pi dapat yung example ko. Fail yung ginawa kong meme. Dapat nga pala si square root of 2. Kasi si square root of 2, yung pinrove natin earlier or last meeting to be an example of an irrational number. A number that cannot be written as a ratio of two integers. Alright? So ngayon, nadagdagan na naman yung set of real numbers. Nagkaroon ng set of irrational numbers. We'll denote it by Q complement or Q upper C. Alright? And then, luckily, siguro later makikita natin na kumpleto na yung real number systems yung real number system natin if we will take the union of the set of rationals and the set of irrationals. And complete in what sense? Titingnan natin yan later when we talk about the completeness axiom. So basically, that's what we have done in the from last week. So in a nutshell, yun yung ginawa natin. So I think now we are ready to learn two more axioms, which are basically called the order axioms. So tapos na tayo sa field axioms, pero kulang pa rin yan. Because we want to develop the set of real numbers in such a nice way, mirroring what we had been using since our elementary days. Tapos kailangan natin mag-assume ng isang ordering relation among the real numbers. And that's what A10 and A11 are for. So if you look at axiom 10, and this is usually referred to as the trichotomy axiom, all right? So for any real number A, exactly one of the following holds. Here, curly P denotes the set of positive numbers. So curly P, or the set P, is a subset of R, okay? So si P ay isang subset ni R. Ang tawag natin kay P, siya yung set ng lahat ng mga positive numbers. Excuse me, guys. But for now, forget about the notion of positive numbers that you learned before kasi ngayon pa lang natin siya i-define. So ang set of all positive numbers or yung pagiging positive ng isang real number is another abstract concept na ngayon pa lang natin bibigyan ng meaning, and we need A10 and A11 to define exactly what it means to be a positive real number. Okay? So kailan or ano yung properties ng subset na to? Ano yung properties ng set of positive numbers? Well, nandun siya sa trichotomy axiom. Sabi ng trichotomy axiom, pag meron kang isang real number, may tatlong possibility. And hence the prefix tri here. So meron kang real number A, tatlo yung posibilidad. Una, si A ay equal kay 0. Si A yung additive identity. Second possibility, A is a positive number, or is that A is an element of the set of positive numbers. Okay? Or yung third possibility, yung additive inverse ni A ay positive. Remember, I am not reading it as negative A kasi wala pa tayong notion ng negative. So our interpretation here is that this is the additive inverse of A. So either A is 0, A is positive, or the additive inverse of A is positive. So yun yung parang madideduce natin sa A10 na ang isang number pala at saka ang inverse niya ay hindi pwedeng maging parehas positive. Only one of them should be positive because of the trichotomy axiom, which tells us that exactly one of these three possibilities can occur or will occur. All right? Now, A10 is not enough kasi parang ano lang to, wala tayong criteria or criterion para masabi kung kailan ang isang number ay positive or kung yung additive inverse niya yung positive. All right? We need to introduce another axiom in order to characterize ano yung laman ng set of positive real numbers. And here we have the sort of the characterization or basically the test para masabi na positive ang isang real number. Okay? Now, if or yeah, or a version of it or an equivalent statement of it can be used to show that a number is positive, okay? But essentially, A11 tells us that if you get two positive numbers, say A and B, then their sum must be positive and their product must also be positive. So, yung sum ng dalawang positive numbers being a positive number and their product being another positive number is an assumption that we impose. All right? So, kasi nga hindi pa tayo marunong mag-add or mag-multiply, all right? So, nililay down natin yung mga properties. Ganun din sa pagde-determine kung siya ay positive o hindi. So, positive siya kapag or pag meron kang dalawang real numbers na positive, pag in-add mo sila, positive yung makukuha mo. Pag minultiply mo sila, positive pa rin yung makukuha mo. So basically, A10 and A11 governs yung pagiging positive ng isang real number. And A10 and A11 are collectively known as the order axiom or the order axioms. Okay. Now, we will now define what a negative number is. A number A is negative kung yung additive inverse niya ay positive. Okay. So, I hope that's clear. So these are ideally the first time in 155 that we are seeing the terms positive and negative. Though minsan nagagamit ko siya in our discussions last week. Pero ngayon pa lang natin sila dapat ginagamit. All right? Now, with the aid of the definition or these characterization of positive and negative numbers, yes, David, do you have a question?
Sir, question po. Sabi niyo po kanina, i-forget muna natin yung positive numbers. So, saan po natin i-start siya i-remember po? Kasi kung sabi po niya yung curly P is set of positive numbers.
Mm-hmm.
Paano po yun, sir?
Or
do we just assume it now po?
After ng theorem 1.5. Okay? So, doon pa lang natin babalikan yung alam natin as positive and negative numbers. Kasi ngayon, ang pwede pa lang natin gamitin ay etong A10 saka etong A11. So, na ang isang number either ay 0, positive, or yung additive inverse niya yung positive. So, yun pa lang yung alam natin about positivity. Alright? Saka yung A11. Alam lang natin, pag nag-add ako ng dalawang positive at nag-multiply ng dalawang positive, yung mga results ay positive pa rin.
Basta so ngayon, po, tawag natin, sir, is positive. Hindi pa natin exactly alam what it means.
Right. So, ang tawag natin ay positive, pero hindi pa natin alam sino yung mga positive. Halimbawa, si 1, hindi pa natin alam na siya ay positive. Kasi pwedeng si 1 yung maging positive, pwede rin si negative 1 yung maging positive, right? Pag binasa natin itong A10. So, dun sa theorem 1.5, dun pa lang natin sisimulang busisiin sino yung mga positive saka sino yung mga negative. But for now, being positive is an abstract concept. So alam lang natin may set of positive real numbers pero hindi pa natin sure kung sino-sino sila. Okay?
Okay po. Thank you, sir.
Alright. So, wag niyo munang alalahanin yung positive at saka negative from before. Alright? Now, before we proceed there, tingnan muna natin, i-define natin yung less than saka greater than. Ito yung isang partial order or actually isa tong total order on the set of real numbers. Okay? Now, sasabihin natin na si A ay less than B kung si B minus A ay positive. Okay? So, A is less than B if and only if B minus A is positive. Remember, we already defined what B minus is, B minus A is, right? Ito yung B plus the additive inverse of A. Alright? So, kung ang B minus A ay positive, then ang A ay less than B. Similarly, we say that A is less than or equal to B if and only if either B minus A is positive or A is equal to B. A is greater than B kung ang positive naman ay si A minus B. Tapos, si A ay greater than or equal kay B if and only if si A minus B ay positive or si A ay equal kay B. So, ito lang yung pwede nating definition ngayon, pwede nating gamiting definition ngayon para sa less than, greater than, less than or equal to, or greater than or equal to. All right? So, para mabigyan natin ng ibig sabihin, kasi wala pa tayong notion ng sino yung mas malaki. Alright? So, ngayon sabihin natin si A ay mas maliit kay B kung yung B minus A ay nagbe-belong dun sa set of positive numbers. Alright? Now, we will also assume the symmetry of these relations. So, kapag ka si A ay less than B, kaparehas yun ng B is greater than A. And then, ang A less than or equal to B is equivalent to B greater than or equal to A. Nakita nyo ngayon na parang ano tayo ngayon, mga abogado tayo ngayon, na pag hindi nasusulat, hindi natin siya pwedeng gamitin. Kaya ngayon kahit yung mga maliliit na bagay, yung pagiging negative, kung yung inverse niya ay positive, kailangan ko siyang isulat. Kasi nga gawa ng meta-axiom of ignorance. We have to refer to something to justify all of the statements that we are making. Yun yung kagandahan ng axiomatic method. Walang tacit assumptions aside probably from the undefined terms and the axioms that we are laying down. Okay? So remember these definitions because we will play around it or around these when we prove some of the nice theorems here. Statement 1.5. Okay? And then probably let's try to prove some of them impromptu. And then siguro pag-isipan ko kung dito ako kukuha ng susunod yung homework which will be due on Monday. Okay? Now, let's try to prove some things. Siguro let's start with statement 1. And then probably while we are doing statement 1 or proving statement 1, you can think of the other theorems that you want to prove. I'm thinking of proving 1 and probably the first half of theorem 6. Tapos siguro kaya nyo na yung iba dyan. Alright, let's see. But you can suggest any other statement that you think is worthy of proving in class, okay? Or gusto nyong makita kung paano siya ipoprove. But I think example 1 is a nice statement kasi dito natin gagamitin yung definition ng pagiging positive para masabi na merong transitive property yung less than relation, okay? Because theorem 1.5.1, tabayin ko na lang siyang theorem 1 for now, alright? Sinasabi niya kapag ka si A ay less than B, tapos si B ay less than C, dapat si A ay less than C rin. Okay? Let's try to write a proof here. Okay? So I will let A, B, and C be three real numbers. All right? Satisfying. Okay? Pwede ko sabihin dito, such that. I use ST for such that. Okay? Pwede nyo rin gamitan sa XOR yung ST kasi standard abbreviation naman yung ST. All right? Such that A is less than B and B is greater than C. Okay? Ito yung mga assumptions. Remember, this is the if part and this is the then part. So we want to use some logical arguments to get from these two assumptions to the conclusion that A is less than C. Probably you can write here, pwede nyo sulat WTS para makita nyo yung ano yung end goal. So WTS, we want to show that A is less than C. All right? Or in other words, paano nga natin masasabi na si A ay less than C? Can anybody remind me? Kasi ang gusto ko mapakitang conclusion ay si A ay less than C. Pero ano yung working definition? How can we get to A less than C? Ano yung kailangan nating ipakita para makarating doon? Kasi ang A less than C, parang ano lang yan, abstract symbol. Pero how can I get there? Yes, David?
Sir, masabi po natin na A is less than C if C minus A is nasa positive numbers po.
Okay, great. That's correct. And I like how you stated that that characterization na si C minus A dapat miyembro ng set of positive numbers. You could have incurred deductions if you have said na C minus A is greater than 0. Remember, we don't know the definition we're using for positive for less than is based on the set of positive numbers, right? So hindi nyo pa pwedeng sabihin na lahat ng numbers na greater than 0 ay positive. We haven't proven that yet. All right? David is correct in saying na ang gusto nating ipakita si C minus A ay element ng set of positive numbers. Okay? Kasi ang problema nga, hindi pa natin kilala sino yung mga positive numbers. All right? So we want to get here. And the only way to go there is to use the assumptions. Let's try to break down what are the assumptions and what can we get from them. Okay. So note that from the first assumption, A less than B is equivalent to saying that B minus A belongs to the set of positive numbers, all right? By definition ng less than relation. And B minus C is equivalent to saying that C minus B is another positive number. Okay? Now, ito yung meron tayo ngayon. Ito yung gusto kong ipakita. Any suggestion what to do next? Yes, Prince? I think magcha-chat si Prince. So, yeah, go ahead, Prince. Type mo na yan. While waiting for Prince. Okay, thank you, Prince. Bilis ng type Prince. So, yeah, that's perfect. Prince is saying na kunin ko yung sum netong dalawa. Okay? Because probably he noticed that when I take the sum of these two guys, I'm gonna get C minus A. All right? So let's do that. So now I'll take B minus A plus C minus B. I'll be a little careful here and write it as B minus B plus C minus A. I used a combo of A1 and A2, all right, commutativity and associativity several times here, and their combination. And then this is 0 plus C minus A, okay, by the 0 property. So that's going to be A3. And then this is C minus A. All right. But what can I say about C minus A? Or dadayain ko na lang ba na isulat, okay, ito ay element ng P. Kasi yun yung gusto kong ipakita. But since that is a very crucial part of the proof, I will be looking for a reason here. So kung sinulat nyo tong proof na to, nag-end kayo dito without any reasoning, I cannot give you full credits. Because malay ko ba na kinopya nyo lang talaga yung nandun sa conclusion. I want to see what's the reason. That's probably the most crucial step here. Yes, Michael, what's the reason there?
Kaya po sir naisip po ni Prince na ipag-add po kasi meron po tayong yung axiom 11 po na pag pinag-add po yung dalawang positive numbers po ay yung sum po niya ay positive din po.
Okay, great. Thank you, Michael. That's perfect. Again, B minus A is positive by assumption. C minus B is positive by assumption again. And then since they are two positive numbers, all right, their sum, incidentally, C minus A, all right, is also positive by A11. Okay? So you see, pwedeng naisip ni Prince na, okay, meron ako nito, pag pinag-add ko sila, makukuha ko yung C minus A. And you just need to find a reason why you can conclude that C minus A is positive. And Michael is right. We're going to appeal to A11 to get this conclusion. All right. The sum of two positive numbers is another positive number. So therefore, you end the proof. So yung tatlong dots na naka-triangle na ganito, siya ay therefore, all right? C minus A is positive, so that means A is less than C by definition of the less than relation. And then the most satisfying thing, a black box. All right? So that ends the proof. So meron transitive property ang less than relations sa set of real numbers. Kaya masasabi natin na isang, ano ang tawag dito, math 101 pips. Kapag ka meron kang transitive, symmetric, and hindi pala siya reflexive, no? Kasi less than relation. But yeah, this is an example. Less than or equal to relation is an example of a total order. Kung natatandaan pa ng mga taga 101. All right? So any questions with this? I hope you get an idea on how to work around these definitions. Probably you can write a similar proof for parts 3, 4, and 5 of this theorem. Okay? Baka yan yung ipa-homework ko. So probably try it out. And I think you can easily think of a proof for it, which is very similar to what I wrote here. So any questions? Okay. So yun pala, hindi ako nag-upload ng annotated notes. If you want, you can take notes. You can write your own notes while we are doing the lecture para talaga ma-simulate yung face-to-face learning environment. If you are more of a techie guy, screenshot nyo na yan. So I'll give you a couple of seconds to screenshot it. Pero I still advise you to write some notes. Meron kasi akong pamahiin. Actually, hindi pamahiin. Ginagawa ko pag nag-aaral ako, especially when preparing for an exam. I always rewrite my notes, either from memory or pwedeng quick glance dun sa original notes ko. I always write it down. At maingay ako mag-review. Usually binabasa ko siya or nagkukulong ako sa kwarto tapos kunwari nagtuturo ako. Kasi I think the best way to learn, or the easiest way to learn, at least for me, is to involve as many senses as possible when studying. So, kung nagbabasa ka lang, only your eyes, or if you are doing silent reading, it's only your eyes that are doing the studying. So, siya lang yung nakakaalala. So, why not add in the sense of our sense of hearing? So, basahin mo siya. So, tatlo na pala yun. Your eyes, your mouth, and then your ears. Sama-sama silang tumutulong sa iyo na i-absorb yung idea. And then dagdagan mo pa ng isa, isulat mo siya. So isulat mo siya habang binabasa mo siya aloud. So there would be at least four senses involved, and I think pag nakalimutan ni eyes, maalala ni ears or maalala ng muscle memory nyo yung mga pinagsusulat nyo. So I think I find it very helpful. So you can try it out and see if that will also work for you. So that's how I do my studying. So, okay, screenshot done, copying done. So I'll delete this part na, and then let's look at another result. Okay, now I promised the proof of part 1 of part 6, or the first half of part 6, which basically is telling us that 0 is less than 1, which is kind of very simplistic, right? Alam na natin, siguro yan yung unang example na nakita natin when we are studying the lesson relation, siguro grade 1 or grade 2, right? But we never ask our teachers kung bakit totoo yan. Tinanggap natin siya sa gospel truth. Siguro mababatukan tayo nung elementary teacher natin kung tatanong natin, ma'am, bakit ang 0 less than 1? Okay? Kasi nga, ang problema natin nun, hindi axiomatic yung development natin nun. So we have to accept this as a fact, all right? Now, let's try to write a proof for this. And I think the proof of this is nicely done by contradiction, okay? Kasi mahirap yung direct proof. If you will try a direct proof, so we want to show that 0 is less than 1, and that is equivalent to saying that 1 minus 0, which is equal to 1, is positive. Gusto nating ipakita na si 1 ay positive. All right? The problem here is there's no operational way to check if 1 is a positive number. Okay? Kasi nga wala tayong enumeration ng set ng mga positive numbers. Right? Kaya sabi ko kanina, kalimutan nyo muna yung listahan nyo ng mga positive numbers because we don't know what they are. Our only basis for the set of positive numbers are A10 and A11. Other than that, we know nothing. All right? So, kung direct proof, magsisimula tayo somewhere, but this is what we want to show. And the problem there again, parang ang hirap ipakita na si 1 ay element ni P. So we need to find another route. And I think one good way of doing this is by doing a proof by contradiction. So when you're doing a proof by contradiction, it would be very helpful if you can indicate so by putting parentheses by contradiction in your proof, all right? So I'm going to prove it by contradiction. And again, in a proof by contradiction, you're assuming that what you want to prove is false. So I will suppose, for the sake of contradiction, that 0 is greater than 1. And I want to prove that there is something wrong. Okay? Now, by definition of the greater than or equal to relation, so either 0 is equal to 1 or 0 is strictly greater than 1. Okay? But we already know that 0 is not equal to 1. Sinabi ko kanina dun sa introduction, we are assuming by our construction that 0 is different from 1. Okay? So, tanggal na tong first case na to. So, we are only left with one possibility. So, ano ang tawag dito, class? Tandaan nyo ba sa 101? Pag meron akong or, alam ko na hindi totoo yung isang disjunct, bakit ko nga makukonclude na totoo yung kabilang disjunct? Anong rule nga yun in logic? Does anyone remember? Anong tawag dito? This is P or Q. P or Q. Not P. Bakit ko na-conclude si Q? Ano yung rule? Tandaan nyo ba? Oy, grabe, Math 101. Pinag-aralan natin to last sem. Yes, Therese?
Sir, yan po ba yung law of excluded middle?
Sorry, Therese, hindi ko narinig. Ano yun?
Sir, yan po ba yung law of excluded middle?
Sorry, napuputol ka dun sa sagot mo. So can you put it on the chat box?
Ay, sige po.
Thank you, Therese. While nagta-type si Therese, anybody? Grabe, magtatawag ako ng mga estudyante ko sa 101. Buti pala ako yung teacher niyo ng 155 kasi kung iba, sasabihin, sino yung teacher niyo ng 101 hindi tinuro yung term o yung logic rule. Okay, law of excluded middle. In a sense, there is, pero hindi siya indirect. Pero nice try though. Medyo malapit na siya. Mga 90% near na. Okay, Prince, type mo rin yung sagot mo. Let's see. John Michael. Tayo na sumagot ni John Michael. Binaba niya na yung kamay niya. But you can also type it in the comments kung wala kang mic. Disjunctive syllogism. Yes, Prince and John Michael got the term that I'm looking for. It's either modus tollens if it is written as an argument, and it's a disjunctive syllogism if you're referring to it as a rule of inference. So that's fine. Thank you, guys. Therese, nice try though. Papunta na siya doon. Yung law of excluded middle, siya yung basis ng proof by contradiction. Siya yung P or not P. So, however, medyo may konti pang step bago pumunta dun sa hinahanap kong term. Okay? So now, we are trying to see the alternative. 0 is greater than 1. Now, what does 0 being greater than 1 mean? So this means, okay, by definition, that is, ano ibig sabihin niya? So that means 0 minus 1, which is negative 1, is positive. All right? So dahil si 0 ay greater than 1, by definition of the less than relation, we know that the additive inverse of 1 is positive. Okay? Good so far? Hindi nyo to pwedeng sabing contradiction kaagad. Kasi nga, tinitingnan natin kung si 1 ay positive, right? So this is still consistent. If we will assume that 0 is greater than or equal to 1, then we will accept for a fact that negative 1 is positive. And it is not violating anything yet. All right? Kasi nga, hindi pa natin alam yung mga laman ni P. So baka naman si negative, si additive inverse ni 1, yung naka-set of positive real numbers. Okay? But labeled to as a theorem, so there should be something wrong. And this is one difficult thing about proof by contradiction. You need to search for something wrong. Hindi specific kung ano yung gusto nating ipakita. Gusto lang nating maghanap ng mali. Something na magiging mali. Right? So kaya walang clear direction kung saan tayo pupunta. So we need to be a little creative with this. So, negative 1 is the additive inverse of 1 is positive. Now, I want to contradict this and find something wrong if I will accept this fact, all right? Now, the key here is, sabihin ko na ba, or anyone with a suggestion? Sige, 30 seconds. Try to think of a plan here. Ano kaya pwede natin gawin? Pero I hope nakita nyo kung bakit hindi pa ako tumigil. Bakit hindi ko pwedeng sabihin na additive inverse of 1 is element of P is a contradiction. Kasi hindi pa nga siya contradiction. Hindi pa clear na contradiction siya. Siya yung magbibigay sa atin ng contradiction. Pero ano yung contradiction na yon? Luckily, we only have a very limited amount of tools at our disposal right now. Kukunti pa yung alam natin. And that the central things that we know here are A10 and A11. And again, let's try probably si A11 yung may sense na gamitin because A11 is the more operational axiom between the two. All right? Sabi rito, kumuha ka ng dalawang positive numbers. Pag in-add mo sila at pinag-multiply, positive number pa rin yung makukuha mo. Now here, if we will accept that the theorem is wrong, then negative 1 will be positive. So it follows that negative 1 times negative 1 is positive. All right? But, okay, ano nga ba si negative 1 times negative 1? Okay, this is equal to 1 by what theorem? I think that's somewhere in theorem 1.3. Okay, there we go. Binilugan ko siya. Yes, siya yung nasa homework nyo. Na negative A times negative B ay equal kay AB. Alright? Paano nyo siya magagamit? Paano siya masasite or magagamit? Well, we simply take A and B to be equal to 1. Kung si A at saka si B parehas na equal kay 1, so this would be additive inverse of 1 times the additive inverse of 1, which we are trying to solve dun sa proof natin. But theorem 1.3.5 tells us that that product will just be 1 times 1. And I'm going to use the identity property of multiplication to conclude that this guy is just equal to 1. So by theorem 1.3.5, we can say, okay, that indeed this product is equal to 1. And we are saying that this is an element of P by A11. All right? And there we have a contradiction. Okay, can somebody spell out for me the contradiction? Bakit ko nasabi na may contradiction? That something is wrong sa pagiging positive ni 1. Who raised their hand first? Yeah, Alex?
Sir, it is stated po sa A10 na only exactly one of the following holds na either A or in that case 1 is an element of positive number or its additive inverse is an element of a positive number or positive number. Tapos, ayun po, nagkaroon po tayo ng 1 is positive. Meron din po tayo sa unahan na assumption na negative 1 is positive.
Okay, so, great.
Yan po.
All right, thank you, Alex. That's perfect. Nagkaroon tayo dito ng contradiction kay A10. Na si negative 1, si additive inverse ni 1 at saka si 1 ay parehong positive. That's a clear violation of our axiom. So, yun yung contradiction. So therefore, what our original supposition that 0 is greater than or equal to 1 must be false. So that means 0 must be less than 1. All right? And then from here, pwede natin nang i-order, pwede na nating alalahanin yung usual sense natin ng pagkuha ng less than or greater than relation. Because for instance, paano ko ba ito mapapakita? 1, 1. Okay. Now, pwede nyo na ngayong balikan kung paano mag-add. Okay, may lisensya na kayo para mag-add at mag-multiply, alright? So, halimbawa, si 1, alam na natin na positive, right? 1 is a positive number because, napakita na ba natin na si 1 ay positive? Yes, 1 is positive because 0 is greater than 1. That means 1 minus 0 is an element of P. And 1 minus 0 is 0. So we know that 1 is a positive number now, all right? Tapos, alam ko na si 1 plus 1 ay positive din dapat. So, ibig sabihin si 2 ay positive din. Tapos si 1 at saka si 2 ay positive din. So ibig sabihin si 1 plus 2, which is equal to 3, ay positive din. Okay? And then, sabi ng theorem 7 or part 7 ng theorem, ang multiplicative inverse ng isang positive number ay positive din. So si 2, ang multiplicative inverse niya ay si 1 half. So si 1 half dapat positive din. Dahil positive si 1 half plus 1 is positive, which so that means 3 halves is positive. Okay? And so on. So makukumpleto na natin yung listahan ng mga positive at saka mga negative numbers. So ngayon, may lisensya na rin kayo para gamitin yung usual notion natin ng pagiging positive at negative. Kasi nga kaya natin siyang i-deduce using combinations of the parts of theorem 1.5. Okay? So, are you getting the hang of axiomatization now? So, ito yung foundation kung bakit alam natin na pi ay greater than 0. Gagamit ka ng combination ng mga statements mula sa theorem 1.5. And that's how fascinating the set of real numbers are. And actually, mathematics in general, because you see, with only 3 undefined terms and 11 axioms so far, nabuo na natin hanggang doon sa order relations ng set of real numbers. And we have enough basis to deduce further theorems galing sa mga results na ito. Okay? Now, do you think you can do some of the other problems here to prove some of the other parts of the theorem? Just try play with it. Gagamitin nyo lang naman so far ay A10, A11 plus definition and less than. Okay? I think it would be a nice exercise for you. So, yun. Ungraded homework. Try to answer some of the problems here. Okay? All right. So, okay, property number 2, or the second part of this theorem, is what sometimes is called the trichotomy axiom. Because if you want to prove theorem 1.5.2, you will just play around the trichotomy axiom A10 plus the definition of less than. Okay? Medyo gusto ko lang yung statement nung A10 ng pagiging set of positive numbers kasi mas minimalist siya. Hindi ko kailangang i-define yung less than before I can state the trichotomy axiom. But you can interchangeably use A10 and theorem 1.5.2 as the trichotomy axiom. So that's fine. Either way, we'll get the same axiomatic system if we interchange those two guys, okay? And then we'll also define now the absolute value of a number, okay? The absolute value of a real number is denoted by this guy. So nakakulong sa dalawang bars yung isang real number. That's the absolute value of A. And it is equal to itself if A is greater than or equal to 0, or the additive inverse of A, or now, legal na rin na sabihin natin na negative A if A is negative. All right? David, may tanong ka ba? Or na-spoil ko ba?
Hindi naman po, sir. Nandito ako slide, sir, sa paano po natin magagamit yung usual conception po natin ng positive and negative numbers using dun sa theorem 1.5.1 and 6, sir? Ba yun, sir? Or pwede na ba natin sabihin na ito greater than ito?
Ngayon pwede na nating sabihin yan, David. Kasi nga, kaya nating i-prove yon using combinations of statements from theorem 1.5. Yun nga yung example ko kanina. Halimbawa, gusto mong i-prove na si 3 halves ay positive or si 3 halves ay greater than 0. Pwede mo simulan sa, alam na natin by this theorem that 1 is positive. So dahil si 1 ay positive, so ang 1 plus 1 dapat ay positive rin, right? By axiom A11, okay? Tapos by theorem 1.5.7, ang multiplicative inverse ni 2 dapat positive din kasi si 2 ay positive. So si 1 half dapat positive din. Alright? Tapos, positive to, pag pinag-add ko sila, ang sagot ay 3 halves. So dapat positive din yon by A11. So and then kung gusto mong i-prove na yung ibang numbers ay positive din, you can just play around these theorems para ma-deduce yun. Pero hindi na natin siya gagawin kasi mahirap naman kung gagamit kayo ng halimbawa pi is greater than 0. Medyo mahaba-habang proseso yung pagpapakita nun. And I will not ask you to do it. Pero the principle behind that is a combination of the order axioms plus its consequences in Theorem 1.5. At least for the basic cases. Siguro si pi medyo mas komplikado yung pagpapakita na siya ay positive. Pero yun yung essence. So to avoid those unnecessary complications, ngayon pwede na nating i-assume yung usual notion natin ng pagiging greater than 0 at pagiging less than 0. Tapos, ang set of positive numbers, alam na natin sila yung mga nasa kanan ni 0 sa real number line. Yung mga negative numbers, sila yung mga nasa kaliwa ni 0 on the real number line. Okay? I hope you I answered your question.
Apo, sir. Thank you.
All right. So, wala na magprove na halimbawa si 5 ay greater than 0. Huwag nyo nang i-prove yun sa exercise. So, assume na natin na alam na natin siya. Kasi gagamitin nyo lang naman yung mga statements sa Theorem 1.5 to show that. Okay? Now, going back, I'm talking about the absolute value. Ito yung mga usual absolute value definition. Finormalize lang natin siya. And it is followed by 3 theorems about the absolute value. Ang absolute value ng product ay product ng absolute values. Statement 2 is the triangle inequality. Okay. Siguro it's another candidate para maging homework, yung triangle inequality, because it is a very important result with implications not only for functions of real variables, but also for functional analysis. Maraming gamit yan, maraming versions. And there are lots of proofs for the triangle inequality. But if I will ask you to prove the triangle inequality, you must just use the results that we already have. Okay? Marami ang proofs. May geometric proof, may mga fancier proofs. Pero kung kokopyahin nyo yun from the internet, make sure that you pick one na ang ginamit lamang ay yung mga theorems na na-state na natin at na-prove na natin. Alright? Statement number 3 is another statement of the triangle inequality, but this deals with ano yung nangyayari pag meron kang minus sign dun sa loob ng absolute value. Okay? So probably later we'll bump into some results requiring us to use the triangle inequality. So we will just appeal to Theorem 1.6, but I will leave the proofs as an exercise for you. Okay? Pero hindi na yan bago, no? So nakita nyo na yan before. All right, let's jump to defining what intervals are. Okay? Dahil meron na tayong konsepto ng inequalities, all right? Tapos sabi natin, madali nang ma-determine yan. Inassume na natin yung alam natin na less than, greater than, or what are the positive and negative numbers are. We can now define what the intervals are, and we will adopt the usual notations. We'll use a bracket kapag ka sa interval kasama yung endpoint, all right? O yung katabi ng bracket. So this is a closed interval, A comma B. Ito yung laman niya, lahat ng x's that are between A and B inclusive. Okay? Now, we will learn later bakit siya tinawag na closed interval. All right? So, magde-define tayo ng closed sets later, and we will see that an example of a closed set is any closed interval. All right? We use parentheses to denote na hindi kasama yung nasa endpoint, right? And this is called an open interval. And again, we will learn later bakit siya tinawag na open interval. Okay? An open interval actually is an example of an open set which we will define later. Pero ang tawag natin dito open interval, laman niya lahat ng x's na nasa pagitan ni A at saka ni B, yung endpoints ay hindi kasali. All right? And then we also have the unbounded intervals, the interval from from A to positive infinity. These are the real numbers that are greater than A. The half-closed interval A to positive infinity, that's the set of all real numbers that are greater than or equal to A. Okay. Tapos similarly, kaya nyong i-define yung half closed interval negative infinity to a, the open interval negative infinity to a, tapos yung mga half open, half closed intervals. Alright? So basta may bracket, yung katabing number hindi kasali sa set. Kapag kasali sa set, pag parentheses, hindi siya kasali. Alright? Everything's good so far? Medyo maraming definitions, no? Nangangati na ba kayo mag-prove ng theorems? Okay? Alright, so dahil dyan, let's try to prove lemma 1.1. Okay. Oh, by the way, are you guys familiar with the term lemma? May mga iba't iba kasi tayong klase ng propositions o statements. May theorem, which is basically, alam nyo, yan yung mga ayaw nyo. Allergic kayo sa theorems kasi pag may nakita kayong theorem, ibig sabihin magpo-prove tayo. Alright? So aside from theorems, may mga terms pa tayong ginagamit. Pwede tayong gumamit ng lemma. Yung lemma usually is a result that is a precursor to a bigger result. So isa rin siyang theorem, pero ang value ng theorem na to kasi ay isa siyang useful tool para i-prove yung mga mas malalaking theorem. Alright? Kaya siya tinawag na lemma. So usually ito yung pinanggagalingan ng mga theorems or ginagamit pag-prove ng mga theorems. And then meron tayong tinatawag na corollaries. Yung mga corollaries naman sila yung direct consequences ng mga theorems. So parang anak siya ng theorem, tapos yung theorem anak siya ng lemma. Alright? Pero lemma are usually small results na talagang pang-prove lang talaga yung utility niya. Okay? And then ano pa ba? Propositions, ginagamit rin siya. Propositions are usually theorems din siya, pero usually ginagamit siyang label para sa mga mas basic na results. Pero they all mean the same thing. They are just propositions needing proof. So, yeah. You can use them interchangeably. Pero pag nakakita kayo ng lemma, conventionally, ginagamit siyang pangalan para sa mga results na gamit, pang prove ng mga ibang theorems. Okay? And since this is labeled as a lemma, expect that we will go back to these even if we are on the succeeding lecture notes na. Even if we are on chapter 4, chapter 5, baka gamitan pa rin natin yung lemma 1.1. Okay? Now, what does this lemma mean? So sinasabi niya, kapag meron tayong dalawang real numbers A and B, tapos sa kahit anong epsilon greater than 0, however small that epsilon is, ang A ay less than or equal kay B plus epsilon, then we can say that A is less than or equal kay B. Okay? So, ano yung essence nito? Kapag si B raw, dinagdagan mo ng katiting na number, epsilon. Usually si epsilon, dinidenote niya lang ay napakaliit na number. So pag nagdagdag ako kay B ng mas maliit na number, or ng kahit anong maliit na number, mas malaki pa rin siya kay A, then that means A is less than or equal kay B. Alright? So kung si B, dagdagan ko na lang siya ng konting-konti ng kahit anong maliit na number, magagaranti ko na mas malaki siya kay A. Ibig sabihin, in the first place, si A, mas maliit na talaga kay B. Right? Kasi nga, nag-work to sa kahit anong epsilon, gaano man siya katiting, ibig sabihin, in the first place, mas malaki na dapat si B or equal siya kay A. Alright? Now, the proof is quite nice. It used a nice trick, constructing a number na ginamit para dun sa pang-prove sa kanya. Okay? And this is done by contradiction. Gusto nating ipakita that if this guy is true, okay, then this must follow. All right? So proof by contradiction, pwede natin tong gamitin as our assumption pa rin, but we will negate the conclusion. Kunwari, mali yung conclusion ng theorem. Okay? But we will use this guy or the assumption in order to derive a contradiction. So since we want to prove that A is less than or equal to B, then we will suppose the negation. A is greater than B. Kunwari lang. Okay? But this will also be part of our assumption in the proof kasi nasa if part siya. Okay? Now, ang sabi nito, kahit anong epsilon pa ang piliin mo, idagdag mo siya kay B, tapos si A ay mas maliit dun sa B plus epsilon, then magpo-follow na si A ay less than or equal to B. Right? So, let's try to see that. Okay. Actually, hindi pala natin ito magagamit na assumption, no? Pero dito ko try na kunin yung contradiction. Okay? I'll try to write something that that is related to this. Okay? So, gusto kong tingnan ano yung nangyayari dito. Alright? So, totoo to sa lahat ng epsilon or gusto nating ipakita na totoo yan sa kahit anong epsilon. So, pumili nga ako ng isang specific epsilon. And for whatever reason, or for reason that will be clear later, ang pinili ng proof na gamiting epsilon of all the epsilons greater than 0, ang pinili niya na epsilon ay si A minus B all over 2. Okay? Now, we are sure that this is greater than 0 because by assumption, we are supposing that A is greater than B. You can see AI greater than B, that means A minus B. So, ibig sabihin nito, A minus B is greater than 0 kasi si A minus B ay positive by the definition of the less than relation. Okay? And probably one of the statements in theorem 1.5. Tapos, si A minus B, pag minultiply ko ng another positive number, again, we said we already know that 1/2 is a positive number. So, ibig sabihin, positive pa rin yung product. And that's what A minus B all over 2 is. All right? So, I hope you are convinced that this is true. A minus B over 2 is greater than 0. And this is one thing that you can do whenever reading proofs. Try to supply the missing information. Okay? At intindihan, bakit niya na-conclude na greater than 0 ito? So, yun yung ginamit. Some statements from theorem 1.5. Okay. And then, ano yung gagawin niya ngayon? So, CA ay less than or equal to B plus epsilon. Let's see why is this true. Okay. So, paano siya nasabi? Kasi nga dun sa assumption natin, dapat ang A ay less than or equal kay B plus epsilon sa kahit na nung epsilon greater than 0. We have here a nice epsilon, which we know is greater than 0. Okay? So that means A is less than or equal to B plus that epsilon that we have chosen. All right? Tapos, simplify nyo to. Kaya sabi ko kanina, pwede nyo nang alalahanin paano mag-add saka mag-multiply. Pag sinimplify nyo yan, makukuha nyo ay A plus B over 2. But A plus B over 2 is strictly less than A. Bakit siya strictly less than A? Strictly less than A siya kasi si A ay strictly greater than B. Okay. Dito, so ibig sabihin ito, A plus B over 2, siya ay magiging mas maliit kapag or actually tama ba? Ito ay mas maliit sa A plus A over 2, right? Kasi si A ay mas malaki kay B. So, ibig sabihin, pag si B, pinalitan ko ng A, yung ito ay mas malaki dito. Alright? But this guy is equal to 2A over 2. That's equal to A. Right? So here what we have is that A is strictly less than A. Right? A is less than A, which cannot happen by trichotomy axiom. We know that A is equal to A. So since A equals A is already true, then A cannot be less than A. And that's the contradiction. So therefore, our supposition is false. So we must accept that A is less than or equal to B. Okay. That is if this statement is true for all epsilon greater than 0. Okay? Okay, you can copy these or take a screenshot. Yes, David?
Sir, doon po sa A plus B over 2 is less than A plus A over 2. Kasi po A is greater than B, sir, di ba? Ano po yung gagamitin naming reason to say that? Transitivity ba siya, sir? Or
actually, kung gusto mo siyang i-prove, magsisimula ka sa A greater than B, tapos mag-addition ka. A plus B. Tapos magmo-multiply ka both sides by 1/2. So halo-halo dun sa statements ng Theorem 1.5. Pero if you will be writing a proof, pwede nyo nang hindi isama itong proof na to. Kasi nga pinayagan ko na kayo na i-assume yung usual less than, usual greater than, and usual arithmetic operations. So no need for the proof of that. So pwedeng dire-diretso na nga ganito. Pero that's a nice question. The proof behind this is a combination of the statements from Theorem 1.5. Okay. And I like your way of thinking na axiomatic ka na ngayon mag-isip, no? Lahat inahanapan mo na ng reason. And that's a good thing, right? Pero pwede nyo nang hindi isama yan. Kasi nga, pinayagan ko na kayo na gamitin. Yung natutunan natin before regarding arithmetic and the less than relations or the order relations. Okay? All right, so I think that ends section 1.4. Let's go to section 1.5. It's another barrage of definitions ulit. Isa lang pala. Kapag ka meron kang isang set S, together with two binary operations on it, satisfying A1 to A11, ang tawag sa kanya ay ordered field. So kapag ka A1 to A9, ang tawag natin sa kanya isa siyang field. The set together with the two operations is a field. Kapag ka na-satisfy niya rin si A10 at saka si A11, ang tawag natin sa kanya ay ordered field. So since we assumed A1 to A11 for the set of real numbers, then we can say that the set of real numbers is an ordered field. Okay? Now there are other ordered fields. Actually, there are ordered fields that are smaller than R. Si QI isa ring ordered field. Kasi you can check that Q together with the usual addition and multiplication, masasatisfy niya rin yung A1 to A11. So Q is an ordered field. Obviously, si R ay ordered field. Walang finite na ordered field. Ipoprove niya to sa math 111. Okay? But another example of an ordered field is the set of algebraic numbers or real algebraic numbers. Ang isang number ay algebraic kapag ka nakahanap ka ng isang polynomial equation na siya yung solution. Okay? For instance, 1 is an algebraic number because 1 is the solution of the equation x minus 1 equals 0. Right? Negative 1 is also an algebraic number because it is a solution of x plus 1 equals 0. So basically, lahat ng integers ay madaling makita to be an algebraic number. Lahat din ng mga rationals ay algebraic number din. Halimbawa si 2/3. Ano yung equation na ang solution ay si 2/3? Pwede kang mag x equals 2/3, 3x equals 2. So 3x minus 2 equals 0 is a polynomial equation whose solution is 2/3. So we can say that 2/3 is another algebraic number because it is a solution to some polynomial equation. Now, so lahat din ng rationals ay solutions din ng isang polynomial equation. So sila rin ay mga algebraic. Pero ano pa bang example? Si square root of 2, though irrational siya, isa rin siyang algebraic number. Kasi si square root of 2 ay solution nitong polynomial equation na to. Right? Remember, when we say polynomial, dapat yung coefficients ay integers. Alright? Or pag sinabi kong polynomial equation, dapat yung coefficients niya ay puro integers. Alright? So, saka siya naging algebraic number. So 2 minus x squared equals 0 has square root of 2 as its solution. So square root of 2 is another algebraic number. So ito yung ordered field na mas malaki kaysa kay Q kasi meron siyang mga irrationals, pero mas maliit siya kay R. Kasi si pi, si E, sila ay hindi mga algebraic numbers. So they are called transcendental numbers because these numbers are not solutions to any polynomial equation. Wala kang polynomial equation with integer coefficients na ang solution ay si pi at saka si E. So ang tawag natin dito ay transcendental numbers. So ibig sabihin, may mga real numbers na hindi algebraic, so kaya mas maliit yung set of algebraic numbers kaysa sa set of real numbers. But nevertheless, the set of algebraic real numbers is another ordered field. Okay? So maraming iba't ibang klase ng ordered fields. Now, the set of real numbers stands out among all of these sets because the set of real numbers possesses one nice property, and that's what we call the completeness property. So we have sort of a completeness axiom that only R will satisfy among its subsets that are ordered fields. So siya lang yung ordered field, walang subset si R na ordered field na may completeness axiom o na nakakasatisfy ng completeness axiom. That's why sinabi ko kanina, the set of real numbers is a complete set. Actually, it's a complete ordered field kasi nasa kanya na lahat. Kaya lang, hindi tayo pumapayag sa math na parang abstract yung concept. Kailangan natin siyang mabigyan ng isang working definition. All right? So hindi kasi walang notion yung completeness. Kailan mo masasabi na kompleto na yung isang set? All right? What does it take for a set to be complete? Now, yun yung itatry nating i-define sa section 1.6. Okay? And again, this is the distinguishing characteristic of the set of real numbers from its subsets that are also ordered fields. Siya lang yung complete. Now, maraming version ng completeness axiom. The most abstract of them is Dedekind's completeness axiom. Ano yung sabi ni Dedekind? Ito yung A12, alright? So ito yung axiom natin for completeness. So suppose you have two non-empty sets, A and B, of real numbers. Tapos nasasatisfy niya yung dalawang properties. Una, kapag meron kang element ni capital A at isang element ni capital B, yung element na yun ni capital A ay laging mas maliit sa element ni capital B. Alright? So all members of capital A are smaller or are less than elements of capital B. So kung babalikan natin yung real number line, okay? Meron ka dapat A, meron kang B. Alright? Lahat ng elements ni A nandito lang sa kaliwa. Lahat ng elements ni B dapat nasa kanan. Kasi pag may naligaw dito na element ni B, mas maliit na siya dun sa element ni A. So, hindi pwede. So, pwede yung isipin na lahat ng elements ni capital A ay nasa kaliwa ng kahit na anong element ni capital B in the real number line. Right? Yung real number line ay arranged using the less than relation. Okay? Then we have a property number 2, which tells us that A union B must be equal to R. So basically, what we are saying here is that capital A and capital B partitions the set of real numbers in such a way that members of A are always less than members of B. So dapat meron ka dyan division. Okay? So pwede mo natin maging isang halimbawa dito, so pwede natin sabihin ito yung mga members ni capital A, tapos ito yung mga members ni capital B. Right? So ganito lang natin siya pwedeng i-drawing, right? This is the only possibility. Actually, hindi pala. May isa pang possibility. Ito yung shaded, ito yung open. But yeah, I think those are the two possibilities for the set A and set B. All right? Para ma-satisfy mo yung A12 saka yung dalawang conditions ni A12. All right? So everything in A is to the left of anything in B, and that A and B A union B contains all real numbers. Okay. Now, ano yung property ng completeness? Well, it tells us that A12 tells us that if you have these two sets, then there will exist a unique real number C. Nag-iisa lang, yung real number C, such that si C ay mas malaki sa lahat ng members ni A. Kapag ka si C ay mas malaki sa mga ay mas malaki kay A, ibig sabihin si little a ay element ni capital B. But if if you have another real number B which is greater than C, then that number little b is an element of capital B. So parang si C siya yung boundary. Sa kanya ko i-compare yung isang real number, tapos saka ako masasabi kung siya ay element ni A o kaya siya ay element ni B. Okay? it is silent, what will happen if A equals C or B equals C? Kaya free na si C maging element ni capital A or ni capital B. Doesn't matter. The only requirement or the only conclusion of the completeness axiom is that if A is less than C, then that little a must belong to the left set, capital A. And if B is greater than C, then that little b must be a member of the right set B. Okay? Now, yung partition AB, ang tawag natin sa kanya ay Dedekind cut. Isa siyang Dedekind cut. Alright? So kapag meron kang dalawang sets na nasa-satisfy itong properties na to, okay? Then this will follow. You can always find a unique number C such that these two guys are true. It sounds very abstract, yet pag dinrawing nyo siya, napakasimple niya. Meron ka ditong ray. Actually, mafo-force ka. Kung totoo yung completeness axiom, dapat si set A at saka si set B ay parehas rays. Itong ray na pakaliwa, siya si capital A. Yung ray na pakanan, siya si capital B. Alright? So dapat may nag-exist na unique na number C. And I will use this, okay? We will show that Dedekind's axiom is not satisfied by the set of rational numbers. Or actually, it will not be satisfied by the set of the real algebraic numbers. Okay. Bakit? Kasi magkakaproblema tayo kay square root of 2. All right? Because square root of 2 is not rational. We have proven that. Okay. And we will use that to illustrate that the set of rational numbers is not complete. May butas yung set of complex numbers. Hindi pa niya nako-contain lahat ng elements. Kasi para maging kompleto ang isang set, dapat nasa-satisfy niya yung completeness axiom. Okay? Now, bakit hindi nasa-satisfy ni Q? Alright? Pwede ako mag-define ng dalawang subsets ni Q. Unang set A, tawagin kong set A, lahat ng rationals na mas maliit kay square root of 2. Tapos pangalawang set ko ng mga rationals, lahat ng mga rationals that are greater than or equal to square root of Q, square root of 2. Right? So kung ito yung rational number line, kunwari meron tayong rational number line, right? So assume na complete siya. So ibig sabihin kaya ko siyang i-drawing as a continuous line, walang butas. Yung pagiging complete, kung complete siya. Alright? Kaya lang, kung siya ay complete, pwede kong i-consider itong Dedekind cut na to, A, B. Alright? So, pwedeng nandito si square root of 2, kunwari. Okay? Tapos si capital A ay ito. Siya yung left ray. Yung right ray, siya naman si capital B. Okay? You see that A union B is equal to Q. Alright? Tapos, kapag meron akong real number na mas maliit kay square root of 2, therefore, siya ay na kay A. Oh, sorry, hindi pala yan. Yung condition 1, nung pagiging Dedekind cut, kapag lahat ng elements ni A, definitely mas maliit sa elements ni B. Right? Kasi lahat ng elements ni A is less than square root of 2, but all elements of B are greater than or equal to 2, so definitely lahat ng elements ni A ay mas maliit sa lahat ng elements ni B. Alright? Tapos ang A union B ay equal kay Q. So definitely A, B is a Dedekind cut. Alright? So if the completeness axiom is true, then that means square root of 2 must be the unique number C. Alright? Kasi sabi ng completeness axiom, there exists a unique real number C. Kaya lang, so ibig sabihin kung totoo si A12 para kay Q, we should be able to find a unique rational number that will serve as a boundary between the Dedekind cut AB. Kaya lang, ang nakita natin na unique real number, the only real number that is in a position to serve as the boundary C ay si square root of 2. But unfortunately, something is wrong there. Square root of 2 is not rational. Okay? Para si Q ay maging complete ordered field, dapat masatisfy niya si completeness axiom. Yung completeness axiom, masasatisfy niya kapag may rational number na magse-separate sa dalawang Dedekind cuts. Kaya lang, meron akong Dedekind cuts A and B here, defined in this manner, na ang tanging posibleng boundary lamang ay si square root of 2. And again, unfortunately, square root of 2 is not rational. So therefore, we cannot find a number C that will serve as the boundary between the two cuts. So that means Q cannot be complete. Ibig sabihin, pag i-drawing mo yung set of rationals as a line, magkakaroon ng butas yung line mo. Kasi si square root of 2, hindi siya rational number. So may butas yung line na to. Similarly, you can say na, okay, si pi nandito, hindi rin siya rational. So butas din dyan yung rational number line. So may mga pagitan, may mga butas itong line na to. That's why, intuitively, you can think of Q as hindi siya kompleto. Kasi yung line na supposedly i-drawing mo para kay Q following the less than relation ay hindi buo. Meron siyang mga butas-butas. Okay? But that will not happen with R because of A12. We are assuming that A12 is true for the set of real numbers. Remember, this is an axiom. We are assuming this to be true. There will always be a real number. So R is a complete ordered field, but Q is not. Okay? Now, there are interesting characteristics why having a complete ordered field is very important. And we will look at these consequences when we start talking about uh, some important results that that will emanate from the completeness axiom. Pero may isang problema kasi napaka-abstract nung Dedekind cut. But I think it is a nice way to introduce yung konsepto ng completeness graphically. At madaling i-argue na si Q ay hindi complete using Dedekind's completeness. But it is not that easy to grasp, all right? Though geometrically it makes sense, pero mahirap siyang gamitin sa pagpo-prove. That's why before we look at the consequences of the completeness axiom, we'll start our discussion on Thursday by providing a alternative completeness axiom. So magbibigay ako ng isang statement. It's called the least upper bound axiom, which is equivalent to the to Dedekind's completeness. Tapos sabi natin, gusto natin yung isang axiomatic system ay independent. Dapat yung isang axiom hindi provable using another axiom. So kung si A12 ay isang axiom for R, tapos equivalent siya sa least upper bound axiom, all right? So that means one is provable from the other. So we can simply replace Dedekind's completeness by the least upper bound axiom. And the least upper bound completeness axiom is much easier operationally. Mas madali siyang gamitin sa proofs kesa dun sa Dedekind completeness. So we'll talk about these things next time together with the consequences of the completeness axiom. So sorry, 4 minutes over time na pala ako, but do you guys have any questions? I hope everything is clear. I hope you got something new from our discussion today. So if that's the case, then thank you guys for coming and joining me today. Enjoy the rest of the day, and let's see each other again on Thursday. Doon ko na lang ibibigay yung homework, alright? So doon natin pag-usapan yung homework. So bye guys. Have a good one.
Thank you po,
Bye
sir.
po, sir.
Ingat po.
Thank you po, sir.